What's up, guys? Today we're going to talk about display lists. Now, if you don't know what a display list is, this is going to be a very important video for you to watch and to learn, because if you're going to do any type of graphics programming on the Atari, you need to understand display lists and what they are. So let's take a quick look inside Basic Atari Basic and let's find out what they say display lists are, so I can give you the proper terminology. So, the display list is the name used for the list in the Atari's memory that indicates how a screen is to be displayed. It's the programming language that the Antic chip understands, and it's quite basic, but sufficient to provide the screen display. So in other words, a display list is actually a set of instructions, if you will. They're numerical values, just decimal digits, that tell the Antic chip how to set up the display on the Atari. So for example, if you've ever gone into BASIC on the Atari and done some basic programming, you're presented with a text screen with a certain number of columns and a certain number of rows, and it's got a blue background and it's got the ready symbol there and everybody knows what it looks like. Okay, there's a set of instructions that you can modify to change that display. In other words, you've seen games before that have a big set of text area at the top for keeping score, and then the middle of the screen might have your actual players where they're moving across and doing the game, and then at the bottom it might have some scrolling credits. Okay, there's a display list, quote unquote, controlling that display. Okay, so rather than just continue talking about display lists, let's go ahead and go into BASIC, and I'll show you how you can actually get the display list that's used for graphics mode 0 in BASIC, and we'll take a look at it and we'll break down the values and talk about what each value means and what it does to actually control the setting of the screen. Don't go anywhere. This is going to be a good video. Alright, so here we are at the Atari computer, and I've got a small program that I've typed out here, and let's go over the program so we know what it does. Line 10 creates a variable called dlist, and what dlist does is it puts together a memory location that represents the display list. The Atari at memory locations 560 and 561, that's where the beginning of the display list is located. You can always find the display list for the current display in locations 560 and 561. So 10 basically goes out there and finds a pointer to our display list. Line 20 creates a loop, 32 repetitions, and line 30 goes through and prints out all the values of the display list, with a comma in between the digits, and then 40 just finishes the loop. So let's run this program, and what you'll see is we've got some various values here. Okay, now I want you to understand, this is the display list for graphics mode 0. Okay. These numbers represent the commands or the instructions that Antic uses to create this graphics mode 0, which is 24 rows by 40 columns. Okay, so what we're going to do is we're going to talk about these values and what they mean, and basically how they are able to tell the Antic chip what to do. So looking at this graphics mode 0 diagram that I've created here, you can see the display list instructions 112, 112, 112, 66, 64, and so forth. These are all 1-byte instructions, and these instructions do various things to set up the screen. They tell the screen to draw blank lines like the first 3 112s do, that each 112 stands for 8 blank scan lines. And then the 66 and the 64 is telling the display list, this is the memory address in memory where we're going to start displaying data. That data could be a picture, it could be text that you want to display on the text screen. It's basically a pointer in memory to where the data is going to start. And the 66 is comprised of a command 64, which stands for load memory scan, plus the number 2, which represents graphics 0. And this will all make sense shortly as we continue to talk about display lists. So there's 262 scan lines that fill a typical TV screen from top to bottom. And it's important to note this entire cycle happens 60 times every second. Now, a single trace of the beam across the screen is called a horizontal scan line. A horizontal scan line is the fundamental unit of measurement of vertical distance. And you can actually state the height of an image by specifying the number of horizontal scan lines that it spans. Some other information: the period during which the beam returns from the right edge to the left edge is called a horizontal blank. The period during which the beam returns to the top of the screen is called a vertical blank. And the entire process of drawing an entire screen takes 16,684 microseconds. And on a side note, the vertical blank period is about 1,400 microseconds. Now, most television sets were designed with what we call overscan, and it means that they spread the image out so the picture edges are off the edge of the television tube. This guaranteed that you had no unsightly borders in the television picture. And as you can see from this diagram, the Atari typically, in its graphic modes, only uses 192 scan lines to take that overscan into consideration and to ensure that nothing is lost on a normal television set. Now, these can of course be overridden by designing your own display lists. You can actually display data in those lines, those 24 blank lines above and below the typical screen to get extra real estate for displaying your screens, especially now that we have modern LCD screens for doing our programming on our gameplay. Now, depending on what camp you come from, old school programming, new school programming, the Antic instruction set may or may not appear at first glance simple or not. But in any event, there's 4 classes of instructions, okay? And what I mean by instructions, we're talking about bytes. Every byte that you give Antic is an instruction, okay? And when I say byte, I'm talking about 8 bits. And as you're going to see in the next few slides, the bits are everything. The bits control exactly what that instruction does. But let's talk about the 4 classes of instructions. The first class of instruction is the map mode. These are your graphics modes like 7 and 8, which display pixels on the screen, but not necessarily characters. Then we've got character modes. These are modes that are used to display text on the screen, such as graphics mode 0, 1, and 2. The other class of instruction is a blank line. That tells Antic to draw a blank line on the screen. And then the 4th class of instruction is a jump, which we'll get into in a little bit. Now, the map mode instructions cause Antic to display a mode line with simple colored pixels, no characters. The character mode instructions cause Antic to display a mode line with characters in it. Blank line instructions cause Antic to display a number of horizontal scan lines with a solid background color. Jump instructions are analogous to the 6502 jump instruction. They reload Antic's program counter, and we'll get to those like I said. And then there's 4 special options, and those special options are display list interrupts, load memory scan, vertical scroll, and horizontal scroll. Again, we'll get into those possibly later in this video or in a follow-up video, as they can take some time to explain. Now let's refer back to our graphics mode 0 display list, and I'm going to refer to this diagram frequently as we're going to be talking about it a lot. You notice the first 3 instructions, and I'm going to start referring to these bytes as instructions to get that concept locked into your mind. The first 3 instructions are 112. So you've got a 112, a 112, and 112. Now let's see how Antic determines that 112 tells it to create 8 blank lines. So here we have the bit structure of an Antic instruction. We've got 8 bits here, and we can see that the 8 bits control a lot of this instruction in telling Antic what to do. Okay, let's focus on the blank line bits first, or the blank line mode class first. So as we can see here, in order to tell the Antic to display blank lines, we need to not only tell it to display blank lines, but the number of blank scan lines we want it to display. So this is where bits 4 through 6 of the Antic instruction come into play. With this 3 bits, or with these 3 bits, we can control up to 8 scan lines, or 8 blank scan lines to be displayed. And let's show you how many combinations you can get out of these 3 bits, decimal values 64, 32, and 16. So as you can see here, if all the bits are set to 0, meaning decimal value 0, we get 1 blank line. If we turn on the first bit, which would give us decimal 16, we get 2 blank lines, and so on. So for those of you who are not bit math oriented, all you have to do is have this chart readily available whenever you're doing display lists and know that a 0 will give you a blank line, 16 will give you 2 blank lines, and so forth and so forth. And if you look back at our graphic 0 display list, 112, which is all the bits turned on, gives us 8 blank lines. So now you understand how to tell Antic to draw either 1 through 8 blank scan lines using this instruction and bits 4 through 6. Let's next look at the mode line of the Antic instruction set. Now this is going to use the first 4 bits of the Antic instruction, and this is going to allow us to tell the Antic chip what mode 2 through 15 we want to use for the next scan line or set of scan lines. So here we can see the 15 Atari graphic modes and the screen formats. You can see the one we've used already, Antic Mode 2, which represents Basic Mode 0. The type of mode that it is, text or graphics, the bytes per line, the columns, the rows, the scan lines, and the number of colors, and also the screen RAM required. But also pay attention to the number of scan lines for the mode lines. So in other words, Graphics Mode 0 or Antic Mode 2 is actually going to use 8 scan lines. Antic Mode 3 is going to use 10 scan lines, and so on. This is important when you're building your display list and calculating how many scan lines you're going to be using in the total display list. Remember, we want to try and keep the number of scan lines at 192 so that if your program is ever being displayed on a classic television, you won't get that roll or interference if you go beyond 192 scan lines. Now, one more important set of bits, or bit should I say, in the mode line command is called the LMS, Load Memory Scan. This is where you tell Antic where your display list actually starts as far as displaying data on the screen. If you look back at our Graphics Mode 0 display list, you'll notice the 3 112s at the top of the display list are there, but we never actually are able to display any data or move our cursor into that blank area. That's because the display list has not yet specified this LMS command of 64. Let me explain to you what I mean by the load memory scan. As we can see here, the fourth byte is the first line of the display mode, and it's a jump address to actually where the data starts in memory for displaying Graphics Mode 0. So 66 is comprised of our 64 LMS command plus a 2, which is Graphics Mode 0. This is the first place in the display list where it's told the first line of our display and where to find it. The next 2 bytes represent the low byte screen address and the high byte screen address in memory of where that data is going to come from. Now the subsequent lines containing the number 2 represent the remaining scan lines that are needed to make up the Graphics Mode 0 text 24 lines. Now if you take the first line of Antic Mode 2 that we specified in the 66, which was 64 plus 2, you add the remaining 23 lines, you end up with 192 scan lines comprising Graphics Mode 0. And this is how Graphics Mode 0 is built in the display list to equal out exactly 192 scan lines as per spec. Now if we take a look at the last 3 bytes, we've got a 65, which is a jump and wait for vertical blank instruction, with a low byte and high byte pointer back to the memory address pointing to the start of the display list. So basically this jump instruction / wait for vertical blank is telling the display list where in memory the display list starts and where to begin displaying all over again. It's basically like a jump back to the beginning of the display list, and all we have to do is turn on bits 6 and bit number 1, which gives us the decimal value 65. So let's take one more look here at the stock display list for graphic 0. Let's go ahead and modify this display list and change those first 3 bytes of the display list to actually make them text mode 2 graphic lines. And let's do that in BASIC. Alright, so here we are at the console, and what we're going to do is we're going to try and remove those 3 blank lines at the top of the screen and replace those with graphic mode 0 text lines. So the first thing we need to do is get a pointer to our display list, and the way we do that is we go dlist equals peak 560 plus peak 561 times 256. That'll get the low and high byte and put that into a decimal form, which we can actually reference it from BASIC. So 39968. So let's take a look at the first memory location of the display list, and we know that's a 112. We've seen that before. The second one is also a 112, and the third one should also be a 112. So basically that 112, 112, 112, 112 is 8 lines, 8 lines, 8 lines, which is 24 blank scan lines. Now we want to replace those with graphics mode 0 text mode lines, and fortunately the text mode 0 mode line, which is ANTIC instruction number 2, happens to also be 8 scan lines. So we can do a direct replacement of 112 with 2 and actually change those blank lines at the top to graphics mode text 0 lines. Now, the way we need to do that is we need to also look at the bytes that are in, let's see, dlist plus 3, which is the 4th byte. That is 66, okay? And that basically is a number that tells the computer that the next 2 numbers following that is going to indicate where in memory the screen display starts. So the reason why display lists on the stock Atari built-in display lists don't start with this 66 command, or should I say 64, which is the LMS instruction, is that they don't want those first 3 lines or first 24 lines to be included in where the cursor is going to go. You'll notice that when you cursor up in BASIC, you can't actually get up to those black lines. It starts back at the bottom. Okay, that's because this 66 command doesn't start first. We've got 3 112s, and they're not even part of where the cursor can go. But what we need to do is we need to take this 66. We also need to take the 5th byte, which is dlist plus 4, which is a 64, and we also need to take this one, dlist plus 5. So 66, 64, and 156, we need to move those up to where the 3 112s are, and then replace 66, 64, and 156 with number 2s. So the way we can do that is we can do poke dlist, the first byte, with 66. We need to then poke dlist plus 1 with a 64. We then need to poke dlist plus 2 with a 156. Now that'll make the first 3 bytes of the display list 66, 64, and 156. So now that we've moved those up as the first 3, we need to replace those 3 with something. They can't just be placeholders. So we're going to poke display list plus 3 with a 2, meaning graphics mode 2, text mode 0. Poke dlist plus 4 with a 2, and poke dlist plus 5 with a 2. Now, when I press enter, I want you to watch the top of the screen, and you'll see those three that black area turn into text mode graphics. All right, did you see that? So now our cursor is actually all the way up here, and we're now able to take advantage of those three lines and use those as text mode. Did everybody see how that works? Okay, let's refer back to the display list chart that I built to see exactly what we did. So let's take a look at this graphics mode 0 display list now. What we have is a 66, a 64, and a 156 starting out the display list. And that is basically going to tell the display list to start at the first scan line. We're not going to be skipping any scan lines. And remember, the 66 is the load memory scan command, which tells it, look at the next 2 bytes in memory to get the screen data, which happens to be the text for graphics mode 0, plus the initial starting graphics mode or text mode of that initial scan line. So this first 66 in the 2 bytes is a special combination that tells the display list, hey, we're beginning right here. Now, if you convert 64 and 156 into most significant byte, least significant byte, and turn it to hex, you'll see that it equates to hex 9C40. That is the location in memory where BASIC is going to be looking for the text or the source code for the BASIC program. So I've got a small program here that will list out that starts out in graphics mode 0. The line 10 gets a pointer to the display list, and then line 50 we're going to replace the first 2 lines or mode lines of the graphics 0 display list with graphics mode 2. And then we're going to set the color to purple, and we're going to print the words hello world. So let's run this. And as you can see there, what happened is we basically, if we move our cursor up here, we can basically change these here. Let's clear the screen. And you can see we actually have a text graphics mode 2 up top, and then down here we've got our standard graphics mode 0. So this is a good example of how you can just with a few lines of code modify a stock display list and mix and match different graphics modes to get the screen the way you want it to work. So real quickly, I want to show you guys a basic demo that I wrote last year around Halloween time that basically displayed like a Halloween scene, and it flashed some lightning and there was some sound effects. But I want to show you the source code real quick because I used a custom display list to actually make this demonstration. And if you guys are interested in downloading this program, you can go to the website www.8bitandmore.com, and there's a Hween, I think it's named on the website, or it might be halloween.bas, and you can actually load that up into your Atari Basic and run this demo. There's a couple of graphics files that you need to grab along with it that are actually used inside the demonstration. But what I want to point you to is you can see here in the first few lines of the program that I'm creating a custom display list, and you can also see that starting with line 34, I've got an address in memory 4000 that I'm storing one of the 2 pictures that I'm using to create this demo. And the reason I wanted you to see that was because down here where I actually set up the display list, and I'll do another video that talks about this demonstration in detail and how it works, but looking at line 200 here, you can see we're doing a similar poke here where I'm building my own custom display list. You can see line 210, I'm poking to the beginning of the display list 3 112s. So I'm sticking with the recommended 24 blank lines at the top. And then starting at line 220, you can see that I'm poking my custom address in memory, pick address low and pick address high. That is a memory location 4000 in the Atari's memory, which is up in the higher area of memory. Then I later on in the program actually load a custom graphics 8 drawing into that memory location, and this is exactly where I'm telling the display list to look to display that picture. So this is a prime real-world example of using a display list, a custom display list. And then you can see here in lines 250 and 260 that I'm poking some custom values for a graphics mode 8. that also includes a couple of bits that we haven't learned yet in this video. They'll probably be in a future video, display list number 2, that I'm working on actually right now. But I just wanted you to see this program here. You can download it, you can play around with it, you can look at it, of what you can do with custom display lists. And like I said, I'll have another video that'll be coming up soon that'll actually talk about this program. But let me go ahead and run this program and let it start to work. And what you'll see is right away at the bottom part of the screen where we've got this loading message, you can obviously see that's a graphics 2 mode with the large text that I'm actually loading, putting a display in a loading message there. And then you can see at the top of the display, or the 3/4 top of the screen, I'm actually loading from the disk a graphics 8 image file. Now this image file is a Halloween like, screen, like a spooky night scene with a moon and a tree and a spooky haunted house and some tombstones. But I just wanted you guys to see this real quick, as to right away you can see that I've got the screen split into 2 different graphics modes. The top 3/4 portion or more of the screen is graphics mode 8, and the lower, I don't know, maybe 1/7 or 1/5 of the screen is a graphics mode 2, where I can display like some custom text messages, in that large text format. So I'm going to speed this up and let it, finish loading the demonstration so that we can then see what the demonstration does. All right, so we're approaching the final loading of this demonstration, and what you'll see eventually is you'll see some lightning bolts flash down on the screen. You'll see the background change white to black, but more importantly, you'll see the screen shake up and down. Remember that, because that's one of the custom bits that we can turn on as far as horizontal and vertical scrolling on the display list, and we'll talk about that in a future episode. Anyway guys, that's going to do it for today's video. The purpose of this video was just to introduce you to some of the concepts and examples of how to use display lists. I hope it's been informative, and I hope you go search Google for display lists on the Atari. There's a lot of good information out there, a lot of articles and tutorials. Practice, wrap your head around it, get good at it. And the next time we come back, we'll look at display list interrupts, which is going to involve some assembly language because of the pure speed and power that we need that assembly language gives us. And we'll also talk about using display lists with higher resolution graphics modes like number 8, and managing the memory for those display lists as well. So look for the next video on display lists, and until then, please give me a like on the video and subscribe to the channel so that Google's engine will further populate these videos that I'm creating, and we'll be able to reach more Atari users out there. I get a lot of comments from Atari users that have just come across the channel and had no idea that it existed, and they like the content and they really enjoy watching and learning about the Atari. So until then, I'll see you guys next time. Have fun.